Now we're going to look at finding or using all the pieces of a rational function and putting them together. So these are the steps that we're going to use. I'm going to show you down here how we're using them. So the first part is that we're factoring the top and the bottom, or the numerator and the denominator, to find its domain. If zero's in the domain, then find the y-intercept and plot it. So here we've got, there's nothing to factor on the top, so I have x minus 1. On the bottom, it's a difference of squares, so it's x plus 2 and x minus 2. So our domain is that we have x cannot be plus or minus 2. Okay? There's nothing that cancels out in these, so we can find our y-intercept. So if we do r of 0, I get -1 over -4, which is a positive 1/4. So about there. Then step 2 is to write r in lowest terms. So that's seeing if there's any common factors that cancel out. Find the real zeros. The real zeros come from the numerator. And then those are the x-intercepts of the graph. Okay, so nothing cancels out, so we're going to look at the top. So our x-intercepts are at 1, 0, and it has a multiplicity of 1 because it came from this unsaid first power. So it's going to cross at 1. I'm going to put a C for cross. Okay. So step 3, with r written in lowest terms, find the real zeros of the denominator, which means that when we find that, those are going to be our vertical asymptotes. Okay. Because we can't have those two values at -2 and +2, those turn into vertical asymptotes. The exception would be if we have a hole that one of those will cancel out and not be a vertical asymptote anymore. So, but there, in this case, there was nothing that canceled out. So both of those are vertical asymptotes. So our vertical asymptote is x equals plus or minus 2. They both came from a first power, so they're both odd. Okay. So here's 2, so I'm going to make a vertical asymptote there. Here's -2, so I'm going to put a vertical asymptote there. And I'm going to write odd underneath them. And we'll talk about what we're going to do with those in a minute. Okay. Locate any horizontal or oblique asymptotes. Or this is also the one that we called end behavior asymptotes. So then we're going to look at our degrees. So if we look at our degrees here, this is to the first power, this is to the second power. So the bottom is bigger. So then we're going to have y equals 0 for our horizontal asymptote. Notice our vertical asymptotes are written as x equals, and our horizontal asymptotes are written as y equal, or the end behavior asymptote. Okay. Now, the previous asymptotes that you've looked at with your horizontal asymptotes, like in your exponential or the rational ones where we had it in transformational form, you never crossed the horizontal asymptote. Okay, but that is not necessarily true of all rational graphs. You can potentially cross a horizontal asymptote. So in this case, look here, we've got our x-intercept here, which is going to cross at our x-intercept, or at 1, because it's our x-intercept. Okay, so it's okay if we cross it. Generally, you'll have some reason to cross it. We'll talk more about that in a minute as well. Okay, so then there's no even and oddness with your horizontal or end behavior asymptotes. So then if we look at, let's see here, what number were we on? 5. Use the real zeros in the numerator and the denominator of the given equation, divide the x-axis into intervals and determine where the graph. Oh, I actually do this part differently. So this is where I use if it's even or odd. Okay, so this part I don't actually use. You could still use it, I just don't love it. Okay, so what happens is that we're going to use the fact that we've got 3 portions of this graph. This portion to the left of the vertical asymptote, this portion in between the vertical asymptotes, and this portion to the right of the vertical asymptote. So then what I need to do, there's going to be a portion of the graph in each section. So there's going to be a portion here, and a portion here. Okay, but remember that the asymptotes, that it pulls the graph towards that. You will never cross a vertical asymptote, ever, but a horizontal or an end behavior asymptote you can cross. Okay, so if I look here at this graph, I'm going to start with the middle section because that's where I've got some pieces of information. So if I come from this direction and I cross through here, then I go to try and get to my y-intercept, which is above, which means I would need another x-intercept here. I don't have another x-intercept, so I can't be coming from this direction because it doesn't work with my y-intercept. So instead, if I come from this direction, I'm going to cross, and then I can go to my y-intercept, and then I can pull towards this asymptote. Remember that your y-intercepts don't have even a multiplicity and even an odd. So keep that in mind. So then I'm going to go something like this. Okay. So over here you can do that if you have an odd asymptote, that it's going to mimic the behavior of an odd power function. So it'll either look like this, where it's coming from the top and bottom, or it will go the other direction and come from the bottom and the top. Okay? If you have an even asymptote, it follows similar to your even power functions. So on your asymptote, it's going to be either coming from top on both sides of the asymptote, or it's going to be coming from bottom on both sides of the asymptote. Okay? So your end behavior is matching for your even ones and opposite for your odd ones. So if I look here on the right side of this line, I'm coming from up above. So the opposite of above is below. So on this asymptote, I have to come from below. So that means this part of the graph has to come from here. I'm going to pull towards the asymptote though. I don't have any particular reason to cross it. And in this case, I know I don't cross it because we don't have any other x-intercepts. Okay. So then I've got this portion and this portion. So then I could come over here and say, okay, well, if this is an odd asymptote, that means one comes from the bottom, one comes from the top. Well, this one is coming on the left from the bottom, so that means the one on the right has to come from the top. So I come from here, and then I'm going to pull towards my asymptotes. Now, this is just a nice sketch of the graph, right? So I don't have, maybe it was over here more, or maybe it was less steep or more steep. But that's our general gist of the graph. And yeah, it gives us all of our good pieces of information. Okay? And then that gives us our values. Let's see here. Did I miss anything? Domain, y-intercept. I'll label this as y-intercept. X-intercept, vertical asymptote, horizontal asymptote. We could do the range. I'll just throw the range on there. The range is your y values. So notice this part right here is going all the way up and all the way down. So in this particular case, I have all real numbers. They're doubled up in this portion, and then they're doubled up in this portion, but I have all real numbers. So from negative infinity to infinity. So if we look at this second one, we're going to start by factoring the top and the bottom. So if I factor the top, it's a difference of squares. So I've got x plus 1 and x minus 1 over x. I have nothing that can be reduced. So if I look at the denominator, if I set that equal to 0, that's going to be what my x values cannot be for the domain. So x cannot be 0. Then I can find the y-intercept by plugging in 0 for x. So then I just get negative 1 over 0, which is undefined. So there is none, because we don't divide by 0. Okay? So then I look at the vertical asymptotes. Well, the vertical asymptotes comes from setting the denominator equal to 0. I haven't canceled anything out, so I don't need to worry about a hole. So here our x vertical asymptote is x equals 0. It comes from a first power, so this is odd. And then I'm going to put that on here, put odd. We don't have a y-intercept. Notice that would be on our vertical asymptote, and we don't cross or touch a vertical asymptote. So that would be another reason we would know that we don't have a y-intercept. Okay, then our x-intercepts come from setting the top equal to 0 after we've reduced it. There was no reducing. So we're going to have our x-intercepts of plus or minus 1. They have a multiplicity of 1, so they're odd and going to cross. So at 1, It's crossing at -1, it's crossing. Then I'm going to compare my powers, and I have an x to the first over an x squared minus 1. So then that means we don't have a horizontal asymptote, but we've got a slant or an oblique or a slant, oblique, and behavior asymptote. So then if I long divide here, I'm going to have x squared plus 0x minus 1. So x goes into x squared, x times x is x squared. I change the sign. That gives me 0x minus 1. So my remainder is minus 1. Okay. We don't care about the remainder here, so our end behavior asymptote is y equals x. Okay. So you have to remember back from a long time ago how to graph this. So this is a y-intercept of 0 and a slope of 1. So my y-intercept is 0 and my slope is 1. So I'm going to have, this is why it's sometimes referred to as a slant asymptote. And it doesn't have to be a line. Most of the ones that we'll encounter will be lines, but just so you know. So now, and our end behavior asymptotes don't have even or oddness with them. So now I'm going to look at my graph. I've got two sections here. I've got to the left of the vertical asymptote and to the right of the vertical asymptote. So in the left part of this vertical asymptote, if I follow the asymptotes, I could either have a picture that looks along the lines of this or along the lines of this. So I have to decide if what my information tells me which one of those two portions it would be. Because we have this x-intercept here, I want to come from this direction and pull towards my asymptotes. If we came from here and tried to cross and then go, because it pulls towards our asymptote at the end, it would have to cross another time over here, but we don't have any other x-intercept other than these two. So I also know that it can't come and cross and go like this and then pull towards the asymptote because we need another x-intercept over here to do that, and we don't have that. So then my picture is going to look something along the lines of this. This is an odd asymptote, so that means on the left side it's coming from up top, so on the right side it has to be coming from the bottom. So I'm going to come from here and I'm going to cross there and pull towards that asymptote. Okay, now we could have started with the right section and saw, okay, well it's not, if I try to go like this and cross and then pull back up towards the horizontal, no, oblique asymptote, slant asymptote, then we would have to cross the x-axis again, which we don't have that. I know that I'm not bouncing there because that's an odd multiplicity, so I know that that's not a scenario either. So I could have started from this side as well. So our range on this one would also be -infinity to infinity. If we look at the next one, notice here that this is not a difference of squares. It's x to the fourth. So we don't have any... we could solve using like the root property. So if I have x to the fourth plus 1 equals 0, I would have x to the fourth equals -1. So I take the fourth root, but then that will give us imaginary values that don't work. So we're not worried about that part. Okay, so then there's nothing else I can do on the bottom to factor it. So then if I set the bottom equal to 0, that's not what I want to write either. Our domain is x cannot be 0. The not horizontal asymptote, y-intercept, that's what I was going for, is going to be where I plug in 0, so 0 to the fourth plus 1 over 0 squared. Again, we're dividing by 0, so this is undefined, so we don't have a y-intercept. If we look at the bottom and do our vertical asymptote, I have, it's from x equals 0, but it came from a squared, so its multiplicity is 2, so that means that it's even. Then our horizontal asymptote, or end behavior asymptote or slant asymptote, we're going to compare the degrees. Notice here that the top is bigger. I can't synthetically divide because it's not linear, so I'm going to do x squared into x to the fourth plus 1. So that gives me x squared times x squared is x to the fourth. I'm going to change the sign, and then that gives me 1. This is a lower power than here, so that's my remainder. I don't actually care about that. So our horizontal, oh, we're not calling it horizontal. It's not horizontal because it's higher, so we want to call it slant or oblique or an end of behavior asymptote. So it's y equals x squared. So this one is not a linear asymptote. It happens to be a quadratic asymptote. Okay? So I'm going to put the vertical asymptote of 0 on there, and it's going to be even. And then, sorry, I got distracted by my dog. Oh, and then our vertical asymptote, nope, I just did that. And then our end behavior asymptote is y equals x squared. So the vertex is at 0, 0, and then we go over 1 and up 1. And then it's really over 1 and up 3. We probably don't need to be that precise, but that's what it would be. So I'm going to have a picture that looks like that. Okay? And we still have this asymptote going through that portion as well. So then we need our x-intercept. We don't have any x-intercepts here because if we solve this one up top, we get something that's imaginary, which won't be on there. So now on our even, we want to come from the same direction. So if I come from down here, I would need to pull towards the asymptotes. But notice that would make it so that I would have to cross the x-intercept. So if I come from here, I would have to pull towards it and then pull towards my end behavior asymptote. That's the parabola. And then, so we're going to do that here. Now, I'm just estimating where this is. I don't have any information to tell me how far down this goes. I don't have a y-intercept. I don't have an x-intercept. There's nothing that tells me how far down this is. So maybe if we were to plot the points, it would actually be up here. But we're just doing a good sketch of the graph. Okay, because this is even, on the left side, it's coming from up top. So that means since it's even, on the right side, it has to come from up top as well. Same thing up here, that I don't have anything to say where this is. So you can estimate or sketch a graph and that would be fine. So in this case, when I go to do the range, I'm going off of my picture that I created. So I'm at 1, 2, we're going to call that 3.5. So we're starting at 3.5. I have a point there at 3.5, and then I'm going to go all the way up to infinity. Okay. If we look at this next one, we're going to factor the top and bottom. So there's a common 3x on top, so I get an x minus 1. On the bottom, we're trying to multiply to 12, but add to 1. So 4 and 3, the 4 needs to be positive, 3 needs to be negative. I look to see there's no common factor, so I don't need to reduce anything. So the domain is x cannot equal negative 4 and 3. The y-intercept, I have 0 on top and negative 12 on the bottom, so that's 0. The vertical asymptote, we didn't have anything that could be reduced, so it's at x equals negative 4 and positive 3, and both of them are odd because they came from a first power. So now I'm going to put those on there, 1, 2, 3, 4, and then 1, 2, 3. And then we know our y-intercept is 0, which means now I should be expecting an x-intercept of 0 because I have my y-intercept at 0. So then when I go to do this part, the x-intercept comes from the top being set equal to 0. So I have 3x equals 0, which is just giving us x is 0. It came from a first power, so its multiplicity is 1, so it's odd, and it's going to cross. And then from x minus 1, we have x equals 1. The multiplicity is, again, 1, so it's odd and crossing. So I already have 0, 0 plotted. I'm going to put a C next to it for crossing, and then we have 1 and then C for crossing. Okay? And then we're going to check what our horizontal or oblique asymptote is. So here I've got the powers match, so I'm going to take the leading coefficients. So in this case, we're going to get y equals 3 over 1, which is just 3. So 1, 2, 3. So here is my end behavior asymptote, or my horizontal asymptote. So then I need to create my picture. So I've got 3 parts to this graph. This part, and this part. Okay, so notice here that to the left of the leftist vertical asymptote that I could have a portion up here or I could have a portion here. So I'm going to decide based on the information that I have. I have no x-intercepts over here. In order to pull towards, in order to pull towards my asymptotes, I have to have it cross that x-axis. But we don't have any x-intercepts, so I cannot have this portion. So I'm going to come above the horizontal asymptote and pull towards the horizontal asymptote like this. So then my picture is going to go like this. Okay. I neglected to put what kind of asymptotes were vertical asymptotes. Not add. These are odd. So since this is coming from the top on the left, that means it has to be coming from the bottom on the right side. So I'm going to come from here. Notice I've got over here, I'm looking what I've got. I'm going to have this x-intercept, so it's cross, but then I need to hit this one to cross. So then I'm going to come back down to here. So cross, cross, come back down to here. Okay. And then this asymptote is also odd. So on the left, it's coming from the bottom. So that means it has to come from the opposite side on the right. So on the right side, it has to come from the top. So then we're going to have this picture. Okay. So in this case, now I don't have anything to say that we're crossing this horizontal asymptote. So like I don't have an x-intercept that would cause me to come down here or whole, something like that. So I don't need to cross it. I don't have a y-intercept up here that would have me cross it in the middle portion. So I don't have anything here. So that means that for our range, we've got this gap portion here. So our range is going to go from negative infinity to, I'm going to call this height about a quarter. And it touches at the quarter. And then we start back up 3, but we're not touching 3. We're just getting close to 3, and then we're going to infinity. Okay, so if we look at the next one, we are going to factor top and bottom. So on top, we're trying to multiply to 2 on this end, or you can think multiply to 4 and add to negative 5. So to multiply to 4 and add to negative 5, you need 4 and 1, both are negative. So here's my 4, here's my 1, both are negative. On the bottom, it's a difference of squares, so we get x plus 2 and x minus 2. Okay, so our domain, we set the bottom equal to 0, so we get x cannot be plus or minus 2. And we're going to check our y-intercept. So our y-intercept is 2 over negative 4, so negative a half. And then we're going to look and see if we can reduce. We can reduce in this case. Okay, so right down here, I'm going to write whole at 2. Because whatever makes this 0 is going to be your x value of your whole. So we're going to come to this in a minute. Okay. So now I'm going to look at the reduced version. So I'm going to call this reduced of x is 2x minus 1 over x plus 2. So then here on the reduced one, I'm looking at that for the vertical asymptote. So the vertical asymptote is x equals negative 2. And then our horizontal asymptote, you can either compare the degrees on the reduced one or you compare the degrees on the original one. They'll both get you to the same answer. So notice here, you've got 1 and 1 are the powers. So I need the coefficients in front, which is 2. And then here we've got a 2 and a 2, and then we're going to take the leading coefficients in front of that, which is 2 over 1. So either way we do it, we end up with y equals 2 for our horizontal asymptote. Okay. Why did that go fuzzy? Well, I don't know. So then we need our x-intercepts. So our x-intercepts come from setting the reduced part, the top equal to 0. So from the reduced part, we get 1/2. And it has a multiplicity of 1. So it's odd and crosses. So then I'm going to put some of these on my graph. So we have a vertical asymptote at negative 2. That's odd. A horizontal asymptote at 2. And then an x-intercept at 1/2. That crosses. And then we've got a whole. Did I miss anything? Domain, vertical asymptote, x-intercept, y-intercept, horizontal asymptote. Oh. Okay, so for the whole, to find the y value of the whole, plug the x value into the reduced equation. So here I'm going to find r reduced of 2. So I have 2 times 2 minus 1 over 2 plus 2. So 2 times 2 is 4 minus 1, which is 3. 2 plus 2 is 4. So it's 2 3/4. So I'm going to come here, and at 2 3/4, I'm going to draw an open circle, which is a hole or a lack of a point. Okay. So now I'm going to put my pieces together of my graph. I've got 2 sections, this section and this section. So in this left side of the section, I could have one that pulls towards the asymptotes like this, or that pulls towards the asymptotes like this. But notice I have no x-intercepts here, so I can't have it in this lower portion and pull towards my asymptotes. So I'm going to have this part here. Then since this is odd, on the left side we're coming from the top, so on the right side we have to come from the bottom. So I'm going to come from here. Notice, did I put my y-intercept on here? Nope, I did not. My y-intercept is at -0.5. I was checking to see if I missed that one. That was not an x-intercept, but it really was an x-intercept, but it was also, the half was also, well, -0.5 was our y-intercept. So here I'm going to go through the y-intercept. I'm going to cross here. I'm going to come to the hole. We're going to jump over it, and I'm going to pull towards that horizontal asymptote. Okay. So notice here on our range, so notice here we kept the domain as x cannot be plus or minus 2, because at 2 we don't have any x value because it turned into a hole. So that's where your difference lies on your vertical asymptote versus your domain. So your vertical asymptotes are x equals the number and doesn't include the x value for the holes, and then your domain is x cannot equal, and it includes the x values for any holes. Now, if I'm looking at the range, I have all these values here, but I don't have this y value right here, right? Because I hopped over that y value. So I'm going from -infinity all the way to positive 3/4, and I, don't touch 3/4. And then I'm going from 3/4 to our horizontal asymptote, which is 2. And then I'm going from 2 to infinity, because there's nothing that says that I'm crossing this value there. Okay? So then that would be how we do that portion. Oh, that's the end. Ta-da! We did it. Good job.